Hello students, let us continue our discussion on alkenes. So in the last session we have discussed few reactions. In this session we will be discussing some other reactions. The reaction that we are going to discuss is hydroboration and oxidation. The reaction that we are going to discuss is hydroboration oxidation. Hydroboration oxidation is the reaction that we are going to discuss. As the name itself indicates, hydroboration oxidation. Okay, so there are two steps in the reaction. First step is hydroboration and second step is oxidation. Okay, in this reaction alkene is converted into an alcohol using a diborane. Okay, diborane. In this reaction alkene is converted to an alcohol by using diborane and then H2O2. What is this diborane? See, B2H6 is the diborane. So B2H6 is a dimer of BH3. Okay, so boron contain empty orbitals. So hence what happens is, so it forms a dimer. It is a dimer of BH3, diborane, right? Whenever you take an alkene, that means RCH double bond CH2, treat it with diborane, that is B2H6 and then H2O2. You get an alcohol. You get an alcohol in which addition takes place across this double bond. So OH adds to one carbon, H adds to another carbon. Here the addition, the net reaction is anti-Markovnikov's addition of water. The net reaction here is, addition of water takes place. That is anti-Markovnikov's addition. Anti-Markovnikov's addition. That means, what does Markovnikov's addition says? Negative part of the reagent attacks the carbon containing least number of hydrogen atom. So here it should attack. But anti means here the product will be this RCH2 CH2OH. This is what happens. This is the product that you get. So the reaction occurs in two steps. First step, hydroboration takes place, and next step, oxidation takes place. We'll just take this example and we'll try to solve it. So we'll take this example, CH3 CH double bond CH2. Okay, if we treat it with B2H6 followed by oxidation with H2O2, you get this. Right, this is the product that forms. This reaction occurs in two steps. CH3 CH double bond CH2 plus BH3 twice. B2H6 is BH3 twice. So what happens is, first addition of boron takes place. Okay, hydrogen adds here, boron adds here. So there are 3 hydrogen. So this 3 hydrogen will add to 3 such molecules. Are we getting this? So what happens is, we have boron and 3 hydrogen adds to 3 such molecules and boron forms a bond with this. So you get this compound CH3 CH2 CH2, 3 times B is what you get, because it is BH3. Boron is linked to 3 hydrogen there. So what happens, all the 3 hydrogen gets replaced by this one, CH3 CH2 CH2B. So 3 molecules, because if you want to form a bond with boron, boron valence is 3, so 3 such molecules will form a bond here. So first addition of BH3 takes place. Next, this BH3. Okay, so since it is B2H6, so BH3 can form 3 bonds. So what happens is, let us balance this. So 2 boron, 1 boron is there. Let me make this 2. So this will be 6. Next, what happens is this whatever the molecules that you have obtained. Step 2. 2 CH3, CH2, CH2 twice B. Whenever it is treated with H2O2, hydrogen peroxide. Hydrogen peroxide, okay, in presence of a base like NaOH, OH minus, we get this compound CH3, CH2, CH2, OH. So the total reaction is anti-Markovnikov addition of water. So H is added here and OH is added here. So this reaction is called hydroboration oxidation. Right? So to give you some other examples, so whatever may be the case, you can directly write the product. For example, if I want to give another example for this, CH3C, we have this compound CH3, CH double bond CH2, B2H6, H2O2 in presence of a base. What happens? Hydroboration oxidation. Hydroboration oxidation is anti-Markovnikov addition of water. CH3, 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 CH2, CH2, right? Another such a reaction is oxymercuration reduction. Oxymercuration reduction. Right. Now, oxymercuration reduction. This is an excellent method for preparation of alcohols. So in oxymercuration reduction also there are 2 steps. Okay. Now, what generally happens in oxymercuration reduction? See, so if you have an alkene, carbon-carbon double bond, we are dealing with the reactions of alkenes. Alkenes are generally treated with mercuric acetate and water. Okay, CH3, COO twice Hg, mercury acetate and water. Mercury acetate and water. Okay, so in presence of THF, THF is tetrahydrofuran. THF is tetrahydrofuran. Okay, so when alkenes are treated with mercuric acetate, this is step 1, mercuric acetate and water, in presence of THF, it gives hydroxy alkyl mercury compound. This step is called mercuration. So what happens is that addition takes place across the carbon-carbon double bond. Okay, to one carbon OH is attached, to another carbon this mercury part, Hg OC OCH3. So this step is called as mercuration. In second step, this side product that is obtained, you get alcohol. When it is treated with sodium borohydride, they undergo demercuration. Demercuration. Okay, this is what happens. Okay, so oxymercuration reduction occurs in 2 steps. In first step, what happens? Mercuration takes place. In second step, demercuration takes place. Okay, the net reaction is again addition of water according to the Markovnikov rule only. Let's take an example of this, another example, a specific example. I have this compound CH3, CH double bond CH, CH3. I will treat it with mercuric, means CH3 C double bond O. This is like this, twice Hg in tetrahydrofuran. It is a solvent here. So what happens is addition takes place. So this is symmetrical, no problem where you add it. OH adds to one carbon and to another carbon mercury acetate gets added up. OH adds to one carbon, to other carbon mercury acetate adds. Hg OCOCH3. Okay, this compound when treated with NaBH4, demercuration takes place. You get this compound. To butanol. Okay, oxymercuration reduction. Okay, let us take as other examples. So the total reaction is addition of water only, but according to the Markovnikov rule. Whereas when you use hydroboration oxidation, there also addition of water takes place, but it is anti-Markovnikov addition. I have this compound CH3C, CH3, CH3, CH double bond CH2. So when you treat this with mercuric acetate, CH3 C double bond O twice Hg THF. What happens? Addition takes place. OH adds here and mercuric acetate adds here. So it is Markovnikov addition of water only. The net reaction is OH adds to here and H adds here. That is OH minus negative part of the reagent adds the carbon containing least number of hydrogen atom. So you get this CH3C, CH3, CH3, CHOH. OH 3,3-dimethyl 2-butanol. 3,3-dimethyl 2-butanol. So this reaction is also called as mercuration demercuration, because in first step mercuration takes place, in second step using NaBH4 demercuration takes place. So this was about few reactions of alkenes. Now students, the next part, let us discuss some points related to dienes. We come across some compounds which are called as dienes. The name itself indicates di means two, enes means double bond. So compounds containing two double bonds are generally referred as dienes. Dienes are of three types. One is conjugated dienes. Conjugated dienes contains alternate double and single bond. For example, like this, CH2 double bond CH, CH double bond CH2. So these are conjugated dienes, alternate double and single bond. Another type of dienes are isolated dienes. In isolated dienes, so there will be no conjugation. CH2 double bond CH, like this. So this is an alternate double bond, single bond, double bond. It is conjugated dienes. Isolated means there will be a lot of difference there. Next one is cumulated diene. Cumulated diene means it will be CH2 double bond C double bond CH2. That means adjacent only there will be a double bond. This is cumulated dienes. How to name them? Simple. For example, if I want to name this compound, so 1, 2, 3, 4 carbon. So it is but. This molecule is what I am naming. But. Carbon double bond. Okay, butene, right? So there are two double bonds, so we can name it as butadiene. Number it 1, 2, 3, 4. So first and third carbon, so we can name it as 1,3-butadiene. Okay, so this is how you name it. If you have to name this compound, 1 2 3 1 2 3 4 5 pentadiene. 1 2 3 4 1 4 pentadiene is what it means. Okay, so dienes means these are the compounds that contain double bonds, two double bonds. So these dienes can be classified based on the position of the double bonds into conjugated, isolated, and accumulated. Conjugated means double bond is alternate. Isolated means, so there is a huge gap between them. That means they are isolated. They are separated by more than one single bond. So more than one single bond. Cumulated dienes means the double bonds are present on the adjacent carbons. There is no separation of the double bond by a single bond in this case. Okay, thank you.